Hello and welcome to another video. This time it's from a Mechanics 2022 paper and it's question 1, which is on variable acceleration. Once again, I think these questions are really nice on variable acceleration. I really do. I think they're one of the nicest questions in there, and they used to be part of M2 actually, so if you need more questions go to the old M2 papers. But these really aren't bad. The more I look at the mechanics as well, the more I think, well, the one nice thing about mechanics is you can actually really compartmentalize it really nicely into, it seems to have 5 questions on it. There's always one on like the wonky moments questions, there's always one on projectiles, there's always one on variable acceleration, and then there seems to be always one on like an inclined plane, or sometimes flat but forces on a box sort of thing, maybe with pulleys involved. And then finally there seems to be one on constant acceleration or speed time graphs, but we'll look at all of those. But it seems far more predictable in terms of what's definitely going to come up than something like stats is. I think stats is a little bit more of a wild card really. Okay, I'm just going to write this down like that. I hope you can see why this is variable acceleration straight away. It's because when I differentiate this, I'm going to get a function in terms of t, so the acceleration is varying, because remember, s, v and a differentiate to go down 1, integrate to go up 1. That's basically the only rule you need in these questions, and just good understanding of what these actually represent. Okay, find the speed of p at t equals 2. Well, we don't even need to differentiate this here, we just need to find the velocity, because we're going to plug in t equals 2, and 3 times 4 is 12, 2 squared root 2, so that's going to be minus 6 root 2. And so the speed is simply the length of the velocity vector, so it's going to be 144, I've quickly squared 12, plus square that, you're going to get 72, and so it's going to be the square root of 216, did it want it exact, 6 root 6 or 15, let me see exactly what it is to 3 6 fig. When I see square root of 216, my temptation is always to cube root it, but of course that's not what it's telling me to do. So 14.7 meters per second for those of you who love a decimal. Okay, there we go. Part B. Find an expression in terms of t, I and j for the acceleration. So to go from velocity to acceleration, we need to differentiate. So let's just write down the velocity vector. 3t squared minus 6t to the half. And let's get on with differentiating it. So a is going to be, differentiate, you get 6t, differentiate that, you're going to get minus 3t to the minus a half. We'll put it in i's and j's just to be polite. 6ti minus 3t to the minus a half j. Read the question carefully to check we haven't missed anything. T is bigger than 0, that's fine. Looks good to me. Okay, right. Part C, at time t equals 4, the position is 1 minus 4, so r equals 1 minus 4, and often, yeah, I've written s here, but often they use r in these questions in place of s, yeah, so if we want to put r, but just remember it means displacement or position really, in vectors questions, position, displacement from a common origin. Okay, find the position vector of p at time t equals 1, so we need to integrate the velocity. Yeah, and so r equals, okay, 3t squared integrates to t cubed plus a constant, and minus 6t to the half integrates to, but let's put down t to the 3 over 2 first, because we'll increase power by 1, then we're going to do 6 divided by 1.5, that's minus 4 t to the 3 over 2 plus c2. Now we also know when t equals 1, r is going to be 1 minus 4, yeah? Now, if I plug 1 into here, I can see that C1, I'm just going to write by inspection, C1 is 0, because if that was 0, then 1 cubed would equal 1. And plug in t equals 1 down here, you get minus 4 plus C2, so C2 is equal to 0 as well. And hence, R equals t cubed minus 4t to the 3 over 2. Slightly disappointing that both of them ended up being 0 there, but now I'm going to plug in Oh, sorry, no. I've just realised I plugged in the wrong value. Oh dear, what a blunder. Yeah, I plugged in t equals 1 here, but I need to plug in t equals 4. Sorry, people are hammering on my window as well. I've got to go to Roller City in a second, so I'm doing these in slightly rush. So let's spend a little bit more time doing this, a little bit more carefully. So we're going to have 64 plus c1, and then 4 squared is 2, cubed is 8, minus 32 plus c2, and that's supposed to be equal to 1 minus 4. So apologies, I read t equals 1 there and t equals 4 there. Once again, you know, you see the mistakes I make them from reading the questions too quickly and not looking carefully at what I'm doing. And therefore c1 is going to be minus 63, and c2 is going to need to be 28. Okay, so here's our general position. It's t cubed minus 63 and minus 4t to the 3 over 2 plus 28. Yeah. Now I've just got to plug in t equals 1 to find the position vector, and I'm going to get 1 minus 63, which is minus 62, and then minus 4 plus 28, which is 24. And hence, if you like, it's minus 62i plus 24j. There we go. Okay, hope you enjoyed the video. Hope you laughed when I made a little blunder there. Enjoy it, might as well. We all read questions too quickly and stuff like that. It's why we check our answers. Check your answers. Okay, keep up the good work and bye-bye.